Hey everyone, welcome to our second video for kinematics. Today we're going to be talking about the applications of the equations that we talked about in our last video. So with that in mind, make sure to check out that previous video just to give you some context for this one. So we're going to be talking about 1D projectile motion, which is motion just in the y direction. And here, this is the graph that's really helpful when we talk about these sort of problems because you can actually visualize the y position. You begin at x1 here, increase to your maximum height, and come right back down. The key characteristics for this: one, velocity. As the object goes upwards, you have a positive velocity. Coming down, it's a negative velocity. With that in mind, there has to be one position in this movement in which velocity equals 0 meters per second. And for that split second, the object is at 0 meters per second at the very max height. This is because it's the point at which the velocity changes from positive to negative. Acceleration for these sort of problems is always, regardless, negative 9.8 meters per second squared. The derivation of this is related to the gravitational force that Earth provides on an object. More of this will be in other gravitational videos that we will be sharing soon. Depending on if you're on the moon, if you're on a different planet, the acceleration will change depending on that object. Important patterns. First up, we're going to be dealing with maximum height. This is when we have the velocity equals 0, as I mentioned before. So the ball is thrown up at an initial velocity. You reach your max here, right there. And you can use this formula to substitute in the final velocity as 0 right there. And then you can derive it through and find that height, your maximum height. So now we're going to be looking at the total time. When we look at this sort of problem, we have to actually divide the problem into two separate sections. So we know that at the maximum height, the time will be half of the entire time. When we use this formula and set the final velocity equal to 0, we know that at halftime, the time must be equal to negative v divided by a. And that's where we get this equation from, because we know the total time will be double the time to the maximum height. And negative a equals g, and therefore time equals 2 times the initial velocity divided by g. And both of these equations are really, really helpful when we work with other problems because they're really common characteristics that we try to solve for. And of course, you can derive the formula. It's not that complicated, but it can just make the process so much faster. Freefall. And freefall is a very specific type of projectile motion. And this is when the only force is gravity and therefore all air resistance is ignored. It's not very realistic, but it does help us solve for various other situations. There are three main types of freefall. One is when the object is purely just dropped down, like from a building. In all these types of freefall, it's important to keep in mind that the acceleration is always equal to g or negative g, depending on what you describe as the up versus down movement. So in other words, acceleration is always equal to negative 9.8 meters per second. So if it's dropped off the building, know in the situation that the initial velocity is 0 meters per second, and both knowing the acceleration and the initial velocity is usually enough to solve for most of the terms. The second type is when an object is just thrown. So that is, again, just keeping up this metaphor, it's being thrown straight from a building. So we know that the initial velocity will be negative 25 meters per second. And the last type, which is really the most complicated, is when an object is thrown straight up. So of course we know acceleration is negative 9.8 meters per second. We also know, like before from the previous slide, that the time to go up to the maximum position is equivalent to the time to reach the bottom position. And therefore, while going up, the velocity is positive, and the equivalent position relative to the max would be the negative velocity. And at the top, the velocity will be 0, like we mentioned before. And this is an image that's really helpful while we deal with these sort of thoughts. And this is the first example. So that's the initial velocity is equal to 0. It's purely being dropped down. The distance change, or d, is labeled here. And g, which is the acceleration here, is negative 9.8 meters per second. This image does not put negative because it's showing that the arrow is going downwards, and therefore here acceleration is labeled as negative g. So just keep that in mind, that the negative and positive can change depending on your reference frame. Thank you so much for joining me today. Make sure to subscribe, like, and comment on this video and on the STEMI channel. Make sure to check out all of our other videos that are really helpful for various STEM subjects. Thank you so much for joining me here today.